Hello everyone, my name is Prithviraj. This is the second video of ALP programming for ARM7. Yesterday we have created this folder over here. Let's start. Now I am going to open the Keel Vision 4 software. The yesterday's program has been directly opened for me. If this does not come for you, you can click on the project over here and click on open project. In the folder you have created yesterday, that is ALP for ARM7, you can see this source file. You can click on this and click on open. For me it has been already opened. Yesterday we have seen the addition of two numbers. I have also told you that MOV has certain limitations on it. That is, it can take only 0 to 255 decimal numbers correctly. That is up to 8 bits. This 255 is the maximum value for the 8-bit number. So it can take the 255 correctly. So I have given here the 255 number and 10 to the R2. I will save this and I will compile this or rebuild this. 0 errors and 0 warnings. Now I am going to start the debug session. I am going to press F11. The equivalent of 255, that is FF, has been taken correctly. The equivalent of 10 is also taken correctly. Then the both addition is given in R3. There was not a problem at all. Now I am going to stop the debug session and I am going to give the number as 257. I will save this and rebuild it. Now you can see here the error has been occurred, that is immediate. This one cannot be represented by 0 to 255 and rotation. See, this is what I told, that it can take only 0 to 255 numbers correctly. It will take some number about 255, like let me see with 256. I have saved this and rebuilt it. It has taken 256. I will tell you the reason why it is so. And it will not take 258, I think so. Yes, it will not take 258, but it will take 260. See, so now I am going to take you to my mobile screen where I am going to convert the decimal number to binary and hexa. This is the app where I convert decimal to hexa and binary. So let me give the maximum value 255. You can see the value in the binary section over here, that is 8 byte. The maximum value move instruction can take is 8 byte. When I give 256, you can see it is 9 byte. It also is accepted. The reason for this is the last 2 bit on the LSB side is 0. The move instruction will rotate the given binary 2 times. If the carry flag is affected, it will show that error. If not, it will not show it. When I give the number as 257, you can see that 1 has been occurred in the LSB side. That is why the error occurs. When I give the 258, then also the error occurs because the last 2 byte cannot be 1. It is same with 259, but it will accept 260 because the last 2 bit are not 1. In the same way, it will accept the greater numbers also, which does not have last 2 bit as 1. This is same with the hexa number. When I give the FF, remember that the caps lock should be on FF. I save it. It should be 0xFF. The hexa number is given in this way. Okay. I will save it and compile it. 0 errors and 0 warnings. I will start the debug session. And it will accept it correctly and give the result correctly. Now when I change this FF to FF1, it's going to show me the error. See? So this is the limitation with the move instruction. To overcome this, we can use the load instruction, that is LDR, load to register, that is LDR. This is how it looks. Here also you can use LDR. The maximum value for LDR is 2 raised to 32 minus 1, that is 8 times F. Let me show you. This is the maximum value that the LDR can load in R1 for ARM7. I will save this and rebuild it. It's showing me an error over here. This is because for the LDR instruction there should not be hash, there should be an equal to symbol. There should be an equal to symbol for LDR. Now I am going to save this and run this. 0 errors and 0 warnings. Now I am going to start the debug session. The value has been taken correctly. After addition, you can see the number is not as proper as we think. The addition sum is not correct over here. I will tell you the reason for that. Now I am going to stop the debug session. So this is the maximum limit. If I exceed this limit and if I try to compile this, it's going to show me the error saying that numeric overflow. So this was about the LDR instruction. Now coming to add instruction, if you saw that when we started the debug session, let me show you one more time. When we started debug session and when we started running the code by pressing F11, the sum here is not appropriate. For this, the carry flag will be affected, which is in CPSR. To affect the carry flag in CPSR, you should add an S in the instruction. I will show you. Stop the debug session and here you should add S. For this one, if the addition of two number gives the carry, then the CPSR register will be updated by this S. Now I am going to save this by Ctrl S and rebuild it and start the debug session. When I am going to press F11 and again F11 and F11, now you can see that CPSR register has been changed. 2 has been come in the first place. This was not the case in the previous compilation. Let me show you the content of CPSR register. So this is the content of the CPSR register. The C over here is the carry flag. When you give that S in the add, the carry flag is affected. This 4-bit is 1 digit over here. So that 2 represent that this is 0, the carry flag is 1 and the 0 flag is 0 and the negative flag is 0. So the carry flag has been affected because of S added over here. So this is an advantage of add S. So till here we have seen the move instruction, LDR instruction and add S. Now I am going to stop the debug session and I am going to show you the errors that the beginner make when they are using the key for the first time. This is called as indentation. This is the comment which I have told in the first video. This is called as the indentation. If you not follow the indentation properly, you may come across the errors. This area is called as the flag area and this area is the code area over here. Here we will write all the flags which are being used in branching and also the memory names which we will deal in the upcoming programs. When I take this to my leftmost part and I am going to save this and rebuild it. See, there has been an error saying that faking declaration of area. There should be a tab space from the first. Let me see what does this do. I am going to rebuild it. There is no error for this. Let me see for this. There has been error for this. Unknown opcode this one. So for the code area, you should start with giving an tab. This is the general mistake made by the beginners. And one more thing is this, the blue color which you see and all this should be in capital letter completely or small letter. So this was one of the error which I have told that you should leave a tab space while writing the code. I am going to see you again in the next video. Till then, bye.